Morning, this is your Stats Sensei, Mr. Spensei, and this is a chi-square test of independence, politics, and news assignment. So, a research firm specializing in political science and media trends seeks to determine whether political affiliation influences news source preference. With the rise of polarized news outlets like CNN and Fox News, that they suspect Democrats favor in CNN, Republicans prefer Fox News, and independents lean towards NPR. They hypothesize that many voters gravitate towards sources that align with their political beliefs. To test this, they surveyed 1,200 registered voters from a population of 8 million. All right, so right there we have a sample size, so we're going to note that down. Okay, this is N, that's our sample size. We also have a population of 8 million. At alpha equal 0.05, does the data suggest that political affiliation is associated with a preference in news source? All right, so first off, I'm just gonna go ahead and start recording my formula just because I can. So my formula in this case is chi-squared, because all chi-squareds are the same, equals observed minus expected squared over expected. I can also start my graph, even though I don't have all the values yet. I know it's going to be skewed to the right. This is going to be 0, and somewhere over here, I'm going to have some chi-squared value. And this right here, my shaded part will be my p-value. So we'll get that in just a moment. All right. Well, degrees of freedom. We can go ahead and work on that. We have 1, 2, 3 rows. So degrees of freedom is rows minus 1. And we have 1, 2, 3 columns. So 3 minus 1, because it's rows minus 1 times columns minus 1. 3 minus 1 is 2. 2 times 2 is 4. So our degrees of freedom this time are 4. All right. So we have almost everything we need, except we have our observed values, but we don't have our expected values. Now, please remember, you don't input the totals. You only put in the uh, the observed values, so the middle part of the table. So we're only going to input the part here that I'm circling in blue. All right. We don't put in the totals. All right, so we're going to enter the matrix. To do that, we're going to press the blue button, and we're going to find the button that says matrix above it in blue. We're going to arrow over to edit. In this case, we have 1, 2, 3 rows. So we're going to make it 3 by 3, and we can just type over what's already in the calculator. So I have 220, 180, and 100. I have 100, 290, 110. And then we have 80, 90, and 30. Now, technically, what we're doing is we're going 400 times 500 divided by 1200. We're doing that for every single one of them, but the calculator is going to do it for us automatically. So I'm going to press blue button and mode. That gets me quit. And I'm going to go ahead and run my test. Stats test. And we're not running a goodness of fit, so we don't want GOF. We just want a chi-squared test because we're running a test of independence. And our observed and expected are in A and B, or they will be. And I end up getting a very, very small p-value and a huge chi-squared. Chi-squared is 75.97. And a p-value of approximately 0. All right. Now I recognize my graph doesn't show that very well. And you go, how did you know it's approximately 0? It's like, well, it means I have 14 zeros in front of that 1. So now I'm going to go observe minus expected. Well, I observed 220. Oh, I don't have my expected value, so I need to go back and get those. To do that, I'm going to go blue button quit, blue matrix, arrow over to edit, and I'm going to drop down to letter B, and there it is. And I'm going to go ahead and go to two decimal places, 166.67, 166.67. And then this one is 66.67. Then 233.33. And then we have 100, 140. So those are my values. All right. I just pulled them straight off the calculator. All right. So remembering when we're doing this, we're only going to use the first one and the last one to to plug into our formula. So in this case, we're going to go chi-squared equals the observed of 220 minus the expected of 166.67 squared over 166.67 plus plus 30 minus 40 squared over 40. Or once again, this is my observed, this is my expected, observed, expected. And of course, the denominators are always the expected value. All right, the inference procedure. This is a chi-square test of independence. All right, the null hypothesis. Well, what are my two variables in this case? Well, my variables are news source and party affiliation. All right, so news source and party affiliation is political party affiliation associated with news source. And that keyword associated told me it's probably independence. So my hypothesis is HO, news source and party affiliation are independent, which means they're not associated. Not associated. And I don't have room to write it, so I'm just write A, I'll put a C on the end. Not associated. All right. The alternative is news source and party affiliation are, we're going to change it here, are not independent. And that means they are associated. All right. So the big difference here is this one says are independent. This one says are not independent. This one says not associated. This one says associated. So make sure you know that they switch. Are independent means not associated. Not independent means they are associated. Conditions, random sample. All right. Well, when we read this thing, they told us we had a random sample of 1,200 voters out of 8 million. All right. Conditions. random sample of 1,200 that was given. Now we need to make sure our sample is not too big. We're going to go, all right, 1,200 times 10 equals 1,000 equals 12,000. And that's less than 8 million. So N is less than 10% of the population. All right. Finally, we're on to number 3. We need to make so that one made sure our sample wasn't too big. This is making sure it's big enough. All right, and we do that by saying that all expected values are greater than or equal to 5. And we're going to refer people to the table above. See table above. And we look and we check, and I see that the smallest the smallest expected value that I have is 40. So we're definitely greater. All right. So we had the probability that chi-squared is greater than 75.97. So the probability that our chi-squared value is greater than or equal to 75.97 is approximately 0. Now I got that off the table, but I'm going to get it off the calculator. If I go stat test, chi-squared test, there it is, 75.97, and I see e to the negative 15. That means 14 zeros in front. So this is going to tell me that this value is, my p-value is approximately 0, and alpha is 0.05. A little approximate sign. Decision. We're going to reject the null. That is a very small p-value is getting rejected. So conclusion. Our p-value is 0, which is less than our alpha equal to 0.05. We reject the null. We got all that information from there. And this time there is sufficient to suggest, and this is where we restate our alternative hypothesis, that news source and party affiliation are not independent. I'm going to make that a big knot. All right, so our p-value is 0, which is less than our alpha equal to 0.05. We reject the null. That whole first part, all of it, came from right there, came from right this square right here. There is sufficient evidence to suggest that news source and party affiliation are not independent. This second part right here, beginning with news source and party affiliation, that's my alternative hypothesis. That's HA that's stated right up there. All right. So just trying to let you know where things come from. Sure hopes this helps. Look forward to seeing you on the next one. Thank you.